Welcome to Physics 2212 Lab 3. Introduction. The purpose of this lab is to show and predict circuits with resistors in series and in parallel, to learn how to use a multimeter, and to learn how resistors and capacitors work. The models and fundamental physics principles that will be explored are the node rule, which is current flowing into a node equals the current flowing out of a node. Loop rule, the sum of electric potential across the loop is equal to 0, and then Ohm's law, which is V equals IR. Preview of main results. Change in V across a complete circuit will equal 0, and when you increase resistance in a circuit, you will increase the charging time of a capacitor. Lab. Okay, the main physics ideas, again, node rule, loop rule, also capacitance, and then Ohm's law. Okay, system and surrounding. My system is the circuit, and my surroundings is everything else. So the circuit comprises of the batteries, the wires, and the resistors in this picture. Initial conditions. So we have 2 amp meters. They're here and here. I have 2 resistors, one 47 and one 100, and then 2 1.5 volt batteries. And then the predicted current is 0.0204. Details of experience. So the I's that were measured equal to 0.015. My resistors, the values you see are the potential difference for each resistor, the ammeter, and the battery, and that was found using the device we were given. And then the sum of the potential difference was 0 across the entire circuit. So across my entire circuit, all those potential differences in voltage sum out to 0. Okay, here's my diagram showing that progression over time, and like how it also equals to 0 based on all of my measurements. Okay, my initial conditions for the capacitor problem is 47 resistor, a capacitor, and then 2 batteries, again, the same current as before. And then the details of the experiment is with the 20 ohm light bulb, it took 6 seconds to charge and about 8 seconds to lose charge. And with the 40 ohm light bulb, it took about 20 seconds to charge and about 24 seconds to lose charge. Sources of error could be not measuring with the ammeter properly, the wire not being perfectly uniform throughout, so there could be damage in the wire, so then the electric current is not consistent throughout that wire. There could be other forces in the surroundings not being considered, and then there's human error in the timing and probe usage. What if and what does it mean? So if you charge a capacitor with no resistor, the capacitor would charge much more quickly because the current doesn't have any resistance. And then in the ideal model, it would charge instantaneously, but due to resistance in the wire, it cannot do that. And then in real life, no material has 0 resistance, so this is an impossible scenario. And that is it for the lab. Thank you so much.